Hello and welcome everyone to our Immuno-Precipitation webinar. Today I'd like to give you a nice talk about immunoprecipitation, procedures, pitfalls, and protocol tips. So as an overview to my talk, I first like to give an introduction to immunoprecipitation, what it is, and how it works. I'd then like to go over a detailed protocol regarding immunoprecipitation, analysis via Western blot, then go over some practical examples of how this technique is used, discuss the use of tags and fusion proteins, and finally, the part you're all waiting for is the troubleshooting tips section. So let's first begin with an introduction. So what is immunoprecipitation? Well, IP is a method that enables the isolation of proteins or protein complex from a biological sample. There are three main steps involved. The first is the incubation of the sample with the antibody against your protein of interest. Then, this antibody protein complex is separated from the remainder of the sample, isolated, and then analyzed. So here's a cartoon depiction of the basic principle of immunoprecipitation. As you can see here, we have our biological sample. We then add an antibody of interest to that sample and allow it to incubate. Once there has been sufficient time for the antibody to bind the protein, beads that are coupled to either protein A or protein G are added to the mixture. This is then allowed to further incubate so that the protein A or protein G will bind the antibody. Finally, the sample is spun down to pellet the beads, and this time you'll have in the pellet your beads coupled to protein A or protein G bound to the antibody bound to your protein of interest. And this is the general idea of how all immunoprecipitations work. Similarly, in a co-immunoprecipitation, a sample is isolated, or a protein complex is isolated from a protein mixture using an antibody that is specific for one of the proteins in the complex. So you can see here that some proteins are bound together in a complex. Simply add an antibody against one of those proteins in the complex. This antibody will bind its target protein, which also happens to be bound to other proteins. Similarly, as before, you're adding your beads that are conjugated to protein A or protein G. The beads will bind the antibody, which is now bound to one of the proteins in the complex. The sample is then pelleted, and you can see you've now isolated a protein complex. So what are some of the different ways that IP can be used? Well, first, it can be used to isolate or detect proteins of interest. Another way to use immunoprecipitation is to enrich low-abundant proteins in your sample. This will allow for the detection of proteins that may be present in very small amounts. IP can be used to study protein-protein interactions and protein complexes. It can also be used to identify unknown proteins in a protein complex. And finally, it's very useful for verifying protein expression in a specific tissue. So now that we know what immunoprecipitation is and how it can be used, I'd next like to begin going over a protocol for immunoprecipitation in more detail. As an overview, I'd first like to discuss the preparation of your sample. This will be followed by the use of an isotype control, an additional control of pre-clearing your sample, incubation with the antibody against your protein of interest, finally precipitation of that sample from the protein mixture, washing of the beads to ensure sufficient and specific binding, elution of your sample off the beads, and finally analysis of the precipitate. So to begin with sample preparation, any samples of biological origin can be used. The choice of the buffer will largely depend on the goal of the experiment. So let's first take into consideration the type and amount of detergent. So you want to keep in mind that ionic detergents are denaturing and therefore will dissociate proteins. So this is not the type of buffer you would want to use if you're studying protein-protein interactions. Instead, you would choose a buffer containing a non-ionic detergent, such as NP40 or Tween 20. The amount of detergent will also depend on how soluble your protein of interest is. You next want to consider the amount of salt, and this can range from 0 to 1 molar. The presence of EDTA should also be considered, as the presence of EDTA will actually help with endogenous proteases and help inhibit those endogenous proteases that may be released upon cell lysis. Finally, you want to consider the pH, as you want to maintain a physiological pH. A couple of other things to keep in mind with regard to the lysis buffer is the buffer should always contain protease inhibitors and phosphatase inhibitors. These can come in cocktails or can be added individually. Lysates should always be stored at -20 or -80, and it's advised that you store them in the smallest aliquots possible to avoid freeze-thaw cycles, as multiple freeze-thaw cycles will actually result in degradation of your proteins.